started.
I am.
Should we speak Latin to them?
No, I don't know.
Or English?
It's like the worst thing.
Uno.
Good job. All right. Okay, so
Studio speakers, and there's some good like mic. We should mic up.
awesome.
Yeah.
Yeah.
Actually, we should listen to it.
You know what we should probably do is waste a whole bunch of time talking about things so that they're sitting here listening to class being not about the math that they actually need to
Yeah,
learn.
we can make the better.
And then we'll pause and do the math and come back and just talk about more junk.
Next time you get like starting at the appropriate, please start.
That's a great idea.
You may have to like skip ahead to try.
Right, that's a really good idea. Yep. And not like put in a tag or anything, they can just jump. Just you have to look for it.
Sometimes when you were
This is their punishment for attending classic studies, dealing with this.
sometimes when I like was absent, I thought that like you were gonna not assign homework, but then it was gonna be like right in the middle of the entire recording. You'd be like, oh yeah, Ben, there's no homework or something like in the middle. But like you tell them.
Oh, you mean, I'm gonna embed some home,
And if I-
embed a message in this video?
Yeah. So like if I didn't listen to it, I would have done the homework.
I think that's an excellent threat. There might be a message embedded. Ha ha ha. All right, so our goal today is to go from equation to graph, and here's the thing I need help with. Would you like to, like, do one of you have one that you'd really like to go through, either because you think it is so lovely that it's worth highlighting, or one that you're still wrestling with, like, I feel like I didn't get there, could we please do it together? Or would you like me to just put a problem up there and we all start from scratch?
Let's do
Any opinions? Problem up there out of nowhere for starters? Okay. I think, there's something to be said for what you were asking me about on the question you chose, so maybe we should hit that one today. All right, you know what? So this is not, we're gonna start real basic. We're gonna do a nice basic one and work our way up to something not basic. I don't feel committed to you like memorizing steps. Like I asked you to go through that to make sure you understand the process. I don't need you to write like step one. Oh, step one is exactly that. No, I don't need that. But if that works for you, party on. That has to go away. Oh, look at that. F of X equal. I don't know what just happened. All right, so this is our function. It's time to analyze. Okay, so the analysis I like to start with is, well, first of all, there's something we have to do first. Who can tell me what that is? Have to. No.
Domain.
We can talk about domain. Sure, that wasn't the have to I was thinking of, though it's not disconnected from domain. Elizabeth.
We have to factor it,
Elizabeth said we have to factor.
except for it's already factored.
Except in this case, it's already factored. Why do we have to factor? What is the one thing we have to address before we can keep going?
The zeros.
It's related to domain.
The whole.
The whole. You have to see, is there a hole? If you don't look for the hole first, you could mislead yourself into thinking there's a vertical asymptote that isn't really there, which might be what happened for you. Actually, I think is what happened for you now that I think about it. Or some other things can crop, or an x-intercept that's not really there. So your first task is there a hole? Well, this is already factored and nothing cancels, so no, there is no hole. I don't need you to write that there's no hole in order to show work, but I'll write it for this question so that everybody can follow along. No hole. Okay, goody. So our next things to figure out are, we want our vertical asymptote, our horizontal asymptote, our x-intercept, and y-intercept. And of course, some of these could come up as there ain't none, but we might as well find out for sure. Oh, that's not the right color to go with that. I think maybe we'll go, all right. So there's no hole. Vertical asymptotes come from the denominator equaling 0. Okay, so when does the denominator equal 0, Sam?
When x equals -2.
Is that the equation of a line? X equals -2? It is. So you have answered what a vertical asymptote is. Have I mentioned yet how picky I feel about asymptotes being equations of lines? No, because you read it off a sheet. I hope it leapt out at you as an imperative thing to do. But an asymptote is a line, dotted and imaginary though it is. when you talk about it, you're not gonna say there's an asymptote of -2. You're gonna say the asymptote is x equals -2. So give me the vertical line or the horizontal line or the diagonal line or whatever, okay? Does that make sense? It's picky, but it's important. Ha, also known as horizontal asymptote. We're comparing degrees. What did you say, Eliza?
Y equals 0.
Because?
Because the degree of the numerator is equal to the degree of the denominator.
So you're right, the degrees are equal, but that, you got the wrong rule.
So, because, oh, no,
You want to revise?
I can't. If
Please.
A while.
Should we sing
You
the
can
Jeopardy
play-
song?
you can-
So I was gonna sing the Jeopardy song. I was gonna ask Noah to sing to us while we wait.
Okay.
Noah?
So the answer, or just say.
No, just sing.
Happy birthday to you.
Happy
Classic day. Oh, happy classic day.
No, it's
to you.
Oh, we're ready, thank you.
If the numerator degree is less than the denominator degree, then HA is Y equals 0.
Okay, but that, so it's not bottom heavy in that way. So they're equal, so what do we do
So
now?
if they're equal, then you do then the coefficient of the numerator over the coefficient of the denominator.
Which I would phrase as the fraction of the leading coefficients.
Yes.
And what are the leading coefficients?
2 and 1.
Okay, and this is the equation of a line, a horizontal line, so this is y equals. What is 2 over 1, Eliza?
2.
2. So we have a ha at y equals 2, and a va, you follow me, at x equals -2. Everybody okay? Ha ha ha. There's actually, interestingly, a neighborhood in Atlanta.
Oh, Baja?
Yeah. It says it's
That was
Baja.
really.
Philly Baja.
Were you just looking up?
Because my husband was, grew up there.
Ah,
Virginia Highlands, Baja. Which is not Baja, so I don't know what just happened. X-intercepts. Where did the x-intercept come from? So the asymptotes were what you got a sheet on from me, written by me. Intercepts I didn't write a sheet about, but you know something about intercepts, because you know that an x-intercept will have a y value of 0. And so you're looking at a function that's a fraction. What makes a fraction equal 0? Sam?
Having the numerator equals 0.
Yeah, so the numerator has to equal 0. Please notice denominator equals 0 gives you vertical asymptotes. Numerator equaling 0 gives you x-intercepts. What makes the numerator equal 0, Sam? You might as well finish up.
Having 2x equal 5.
Would you like me to write all this? Okay. If you can eyeball this, I'm good. And what's that?
2.5.
Let's leave it as 5/2, but you're right, when we graph, that will be useful. Talk about y-intercepts, Graham.
It's when x equals 0.
Well done. So what am I going to do?
Set the,
X equal to 0.
you can just plug it in.
I can just plug it in. So really, I'm looking for what is f of 0, right? Which would be 2 times 0 minus 5 over 0 plus 2, which is
-5.
negative 5/2. We good? All right, so our next task. There's sticky graphs if you want them, if that makes you really happy. I will find my version of a sticky graph, which of course is not quite the same idea, but much cooler, frankly.
I mean, that's just.
So there's plenty over there, so you can help us out. All right, it's time to graph. I'm gonna start doing that while you guys get set up. So I can know I have vertical.
Look at all these sticky graphs.
-2. Oh, sticky.
take the whole sheet.
Yeah, sure, it's fine. We have so many in the math department that like they really are available to us. Excuse me. Look, I put my asymptotes on the graph. And now I'll change color because that's an important thing to do. And, ooh, that was funny. And put the x-intercept at 5/2, which Sam told us is 2.5. 1, 2.5. And the y-intercept, which is at -5/2, or -2.5. Looking good. All right, well, we're ready to graph. Asymptotes. Asymptotes are guidelines for your graph. So they're sort of structuring for you where things are going to be. I think tomorrow we end up having a conversation, unless it comes up in the problem we do today, about how it is possible for a graph to cross a horizontal asymptote. Because horizontal asymptotes are about what happens in the extremes of our graph, the end behavior. Whereas vertical asymptotes, I cannot cross. They're representing an interruption in the domain. You with me? So I can't cross a vertical asymptote. I could maybe cross a horizontal asymptote. Not going to happen in this problem. Okay, so I'm going to start here. I'm pretty sure, looking at this, that I know the shape of the graph to the right of my vertical asymptote. Yes? If I felt the need, I could plug in some more numbers. I don't feel the need. Those 2 points are so much information. Okay, that's that piece. So then on the left-hand side, I'm left with having to figure out, is it above the horizontal asymptote or below the horizontal asymptote? There's a variety of ways to approach this. The one that brings me actually the most comfort, because I kind of like the concrete, I need something to do to convince myself, is to go ahead and say, okay, I'm just going to think table of values for a second. What is a x value to the left of our vertical asymptote? Pick a number to the left of -2.
-7.
What a great choice. She could have picked anything. Can you plug that into our function, please, and tell me what you get? -14 minus -19 over -5. Where is that?
Positive.
Positive almost 4, right? We'll call it approximately 4. So if I go to -7, up to 4-ish, does anybody feel confident now deciding which of those 2 zones gets the other piece of our graph? Am I making any sense? Because you're all just sort of sitting there. Okay, so Elizabeth, you admitted, and I appreciate the admission that I need to say this differently. All right, so I have something that looks like this. You okay with the part where we got there? All right, so then I'm left with, I need to know what's happening here. Either it's going to be this, or it's going to be this. So once I plug in a value and find out that that value lands me up above the horizontal asymptote,
Wait, why can't it be in the top right?
because let me draw and then I'll answer, and Eliza just answered me, but hold on a second. And so then that leads me to draw the other piece here. Why can't it be over here, Eliza?
Because it wouldn't be a function.
It wouldn't pass the vertical line test, and it wouldn't be a function. Make sense? All right, so I'm going to erase this. Well, no, I'll leave our multicolored exploratory informational graph right there. How are we doing? Ready for another one?
So it doesn't have to be very exact. You just found one point where like it's kind of like there-ish. There's a line there.
The exactness of it is that any points you find, any asymptotes you find need to be exact.
Yeah, no, I mean like the second half of it. Like when we just.
Well, it has to go through the point that you chose, that you convinced you that you
Yeah, but
chose,
it's not super exact at all.
we could debate that. Yes, this is good. You'd get full credit for doing exactly what I just did. All right, so here's our next one. We need something different, don't we? Do you think we should have a hole? I think we should too. I'm not very well. I sort of want, oh, yeah. That'll work. Okay, what is our first task every single time we're graphing a rational function? Factor. Well, Eliza, must be time.
Take a look, see. X minus 5 plus 3.
That's what you mean?
Yes.
Uh-huh.
And then X plus 2 plus 3.
Anybody notice anything?
Cancel the x plus 3 whole.
Canceling that x plus 3 informs us that we have a hole. Our hole is at -3. Everybody know where that came from? Where the -3 come from? It's the thing that makes the factor we just canceled out equal 0. And now I have to find that y value. I can't plug it into the original, because if I plug it into the original, surprise of all surprises, I'm going to get 0 over 0. Which is one of the least comfortable things for math people. Interesting though it is, that's that's like even more alarming than something over 0.
Wait, that is weird. Why?
It is an indeterminate form. Actually, all those things that don't have determinate answers are indeterminate. Okay, so in this case, what it means is that we have a hole in the graph. Okay, that's great. Another way I can phrase that is this graph, f of x, here, I'll write this. F of x is the same as the graph of, ooh, I didn't want to write that. With a hole in it where x equals -3. Right? So basically what we did is we simplified our f of x expression, but we can't just graph it and ignore the hole because then we're not really graphing f of x. But what we can do is graph the leftovers, x minus 5 over x plus 2, and put the hole in the graph, and then we have the graph. Does that make any sense?
So the whole is the entire x equals -3.
No, it's like, here, I'll go to another page for a second. Suppose we had this. This might make a ton of sense. Let's try it. You let me know. Okay, suppose this was our equation. What could you tell me?
There's a hole.
Thank you, where?
X equals 1.
Okay, so there's a hole at x equals 1. The coordinates of the hole would be 1 comma something. To find the something, we plug back into the leftovers, and we get 3. I thought that was going to happen a little faster, but okay. Right, that's what just happened there? Okay. Could somebody please tell me what the graph of 2x plus 1 is? You shall be leaping out of your chair to tell me because you all know this. Some people are doing this. What is this? Haha, you can't see us. What does this mean?
It means it's a line with a slope of 2 and a y-intercept of positive.
Nicely said. Yeah, you got that, right? It's like setting a computer. Okay, so here's 1, and we're going up to, so it looks roughly like this. This is the graph of 2x plus 1. But the graph of f of x is the graph of 2x plus 1 with a hole in it. So I take my magic eraser and say, oh no, I don't want my magic eraser yet. I'll start with my magic pen that says this is 1. And then I'll take my eraser and say, bam, there's a hole in my graph. Oh, right, I'm still on the eraser. That was fun. Now, admittedly, that's a fairly big hole to announce this, but this would be at 1 comma 3. Okay, what was my entire point? My entire point was the hole is going to be just a hole in the graph of the leftovers.
Is it always guaranteed that the hole will intersect with the leftovers graph?
I think my answer is yes, though I take issue with some of the language you chose because the hole is representing a non-existing thing, so intersecting is a little weird. But yes, the hole is going to be on what would have been the path of the graph. And that's actually the point, which is not meant to be. Okay. So here we are. What is the y value of our hole? Hold on. So Eliza, to your question that you just asked, because it's something that's on the path, knowing where exactly it is basically gives us a point to use in our graphing, even though the way we're going to graph it is as an open circle instead of as a point. So it's really useful. Okay, what's the y value of this hole? Sam, you're doing this.
So would that be 8?
Why? Talk me through it.
-3 minus 5, and then -3 plus 2.
So the leftovers, since this is -8 over -1, which makes you say 8, and you are correct. How are we doing?
Great.
Okay, what else do we have left to look at? Well, we're still looking at really analyzing what's going on for this graph. Can I do it speedily? Is that all right? While you're seeing if you agree with me, I'll get my graph ready to go. Anybody want to ask questions about the things that I speedily went through and got? Anybody disagree with me? Did I make a mistake? We're happy? Ish? Eliza?
I'm confused about the horizontal asymptote.
The degrees are the same.
Yeah.
Fraction of the leading coefficients. Leading coefficients are 1 and 1.
Oh, okay, yeah.
For the horizontal asymptote, it's generally safe to go ahead and look at the original function too. But given that we analyze everything else from the simplified version, we might as well go there. All right, x equals -2. Y equals 1. That's right there on y equals 1. You can't tell. Ooh, look, part of the smart board. I'll change color to make the x-intercept at 5, 0, 1, 2, 3, 4, 5. Y-intercept is at 0, 5, half, so like right there-ish. And then we have our goal to plot. That's exciting. How new and different. -3 up 8. I think this is up to 10, so I'm going to just go with that. I can count if I need to. 1. Yes, it is. Okay. Thoughts about how this graph looks? You're all graphing it, so I'll just ignore you and go ahead and graph it myself. So in this one, I didn't feel a need to plug in extra points because between the 2 points, the intercepts on the right-hand side of the asymptote and the hole on the left-hand side of the asymptote, I kind of had everything I needed. How are we doing?
Well,
Ben is doing well. Would anybody else like to answer my question?
Well,
Swell.
Good.
Can anybody add another letter to the word well or swell?
swelter, sweltering, swelter.
Swelter? Is that like club soda? Slub
I mean, it's like,
soda?
it's really hot. Like we're on fire right now, like we're sweltering.
Sweltering.
I still can't do all that stuff as fast as you do.
Well, no, duh, you haven't been doing it for like 20 years, 25 years.
Yeah, that makes sense.
Every single day. Not really, not really do it every day.
Go home, just do a little polynomial graph.
Well, these are rational functions, but yes, I do actually do a fair amount of those things in my day, but that would be expected given my vocation. But at the point that I was, in 10th grade, I was not doing this all day, every day. Okay. So we've done 2 graphs now that have just like a simple 1 vertical and 1 horizontal asymptote. We're not going to get 2 horizontal asymptotes, but we could get 2 vertical asymptotes. Did any of you have graphs that had 2 vertical asymptotes? Sam, you did?
Yeah.
Would you be so kind as to read us the equation? And we'll go through the one that you picked from homework.
X to the third minus 1 over x squared minus 9.
Wow. This not only has a 2 vertical asymptotes, but also brings up the oblique asymptote. And I'm sort of feeling like, yeah, I'm totally on board. We're going to do this one. Could we do one before it that doesn't have the oblique also? Could we just do one with 2 verticals?
Why?
Because I feel like it's a progression of complicatedness that makes more sense in my head. But I do want to do both of them, so I'm inserting a problem in between these 2. Elizabeth, yours seems to have 2 vertical asymptotes. Tell us anything about it.
I did it wrong.
I don't know. You know you did it wrong?
Yes.
How do you know that?
Because I
Sorry, I didn't mean to call you out.
put it in wrong.
Oh, because there's actually a hole, and so you're feeling differently about it than you did before. Let's find one. Is that what you're telling me?
it's 2 verticals.
All right, you know what? I'm gonna,
How about 30?
How about I just make one up?
Oh.
That'll be fun. You feel okay with that? You okay if I do
I
that?
spend lots of time finding this.
Well, then I want you to feel really bad. Oh no, I don't want one. I'm gonna make, here, oh my gosh, you're also upset with me. I'm x minus 1 over x squared.
What are erasers?
Rubber?
Rubber?
Yeah?
Just wasted some rubber.
Sorry. At least it wasn't lead or graphite. Or brain power. Or money. Substantial money, and I get, okay. Would you like a couple of minutes to collect your information? Without, okay, so I'll pause these people. Consider yourselves paused. Oh, it's frozen, haha. Oh, hey, it came back on here. Wacky. We're back. Ready? No. Can you look over mine before we start graphing? Tell me how you feel about what I wrote. And if you agree.
Yes.
10 agrees, Graham agrees, Noah agrees, Sam agrees, Elizabeth, Eliza, begrudgingly. Okay. All right, let's start graphing then. So we have our asymptote and our asymptote and our asymptote. So
This is a very skinny.
the middle part is very skinny. And we have an intercept. Oh, look at that. What an interesting thing for us to talk about. Oh, maybe we are talking about that today. We'll have to see. Who knows what I'm talking about? What just happened for me? And that's a, no,
It's going to be good stuff on asymptote.
it is, in fact, it's a point on a horizontal asymptote. Fascinating. Interesting. So this was not the best graph I could have chosen for us because there's a lot of like minute detail. So this is what happens when I just make things up out of nowhere. It ends up leaving us in sort of like a tight spot.
If only someone liked another comic in the book.
No, I don't want that. That would be too reasonable. So what should we do from here? What questions do we have? Like, what do we need to be asking ourselves?
I'm doing an expert.
RAM.
What happens in between the two marks, like
Yeah, what are they actually called?
asymptotes,
What kind?
vertical?
Yeah, what happens between the two vertical asymptotes? And could you tell me a number between those vertical asymptotes?
X equals 3.
Right, so it seems like starting to talk about a table might be helpful. So, Graham, when X is 3, what is Y? I know, you're making a face, I don't disagree. 2 over something.
-2.
It's 2 over -1, isn't it?
Yeah.
Isn't it 2 over 1?
I think it's 2 over -1.
Yeah, wouldn't it be -1?
It would be 9 minus 18.
I would say that's signs mixed up on the side.
Well then, so this is 2, oh, that wasn't too bad. 3 comma 2. 3 comma 2. Now, if we really want to know, so there's a number of ways we can do this. We're going to say it's a
-2.
What did I do? You're right. Thank you. Oh, that looks like equals.
Whenever you get something wrong, I always just doubt myself for a little bit.
That's probably a good idea, because then I feel superior, which is our entire goal, isn't it?
Well, oh yeah.
That's fun. And I didn't need to waste any,
No,
rubber at all.
or just smartboard.
Or the graphite.
Right, or smartboard juice.
Yeah.
Okay, so there are some things that we can look at, but I'm not talking about them today, about how to sort of know the shape of this without plugging in more numbers. But really to know the shape of this with plugging in more numbers, we kind of need to know what happens in here. What happens if I plug in like 2.5 or 3.5? Let's team up, shall we? Boys over yonder, 2.5. Graham and the girls, 3.5. etc. Both. And you know what we're gonna do? We're gonna make the classics people sit through us thinking quietly. No.
Does that mean you have are we having that thing where it's like a flatness at the bottom of the graph? Goes down and flattens out?
It's not gonna actually flatten and become horizontal, but what we're trying to figure out is, does it
Because we just.
behave like X squared-ish looking or X cubed-ish looking? And in which direction does it go for each of
Because you
those?
guys got -2.
I got the 2, but then I realized that it's.
Did you get negative, what number are you doing?
We're doing negative
And what did you guys get?
Negative.
What did you guys get?
I got negative
That's what I got
5.
too.
No, I got negative 5 there.
Well, that sounds like a different number. I like a different
When I
number.
was reading about negative.
I got negative 2, but then I realized I wrote 7 halves minus 1 half.
What I'm really gonna do, back on. So we found 2.5 gave us what again? That was you guys, that was -2. And this gave us -10/3.
Yes.
So if we go ahead and put those on our graph, at 2.5, -2, which is so close to that one, and 3.5, -10/3, so that's a little more than -3. So it's like that.
What?
I say because it's behaving like something, you know what, it's the multiplicity of 3, it kind of flattens out
It's gonna-
almost.
Kind of, it's gonna, so we're gonna talk about the multiplicity piece of this in a second. But before we do that, can we find what's happening on the other side? Like, let's ignore between the 2 first. So if we plug in 5, we get 4 over,
1 times 3. 4 over.
so 4/3. So if we graph that, we have 4, so like here, which gives us this piece of the graph. You with me? And if I plug in something, we have a couple of points over here, but let's plug in one more. How about -2? We'd have -3 over, plugging into the factored form again, we'd have -6 times -4. Am I doing this correctly? So that's -3 over 24, or -1/8. Yes? No? So that would be -2, -1/8, small again. Oh, then that's interesting, because it's gonna, like, this is gonna come back up. Like, those were both at -1/8, the blue dot and the purple dot. And we know that the end behavior is gonna be, it's not gonna be a flat line between those. Rational functions aren't gonna just level off flat. They're not gonna become constant. So this piece of the graph is gonna cross our asymptote and come and go through here and sort of come back up
Yeah.
underneath. I don't like the way I drew it, hold on.
And how's that an asymptote?
Because horizontal asymptotes are about end behavior, not about I can't be this.
Okay.
So it's gonna do something like, it's hard to get back up there, it's so close, sort of like that and level off. Hmm.
That seems weird.
Yeah, probably my drawing's also weird. And we're gonna investigate one more, this is, like, I'm
And then the middle part
really
is,
conflicted about this. So I'm gonna read something to you, ready? It's gonna help us here. We are recording, good, all right.
that was, so yeah, we got this far, guys. Catch up.
Okay, so if we have vertical asymptotes, if the multiplicity of our vertical asymptote factor thing, in other words, x minus 4, right, has multiplicity 1. Okay, so if that's odd, then on either side of our vertical asymptote, the function is going to go in different directions. So if we figured out that it's definitely going up here, then we know it's going to go down here.
Because they're both odd.
Because this has an odd degree,
Just the first one.
because we were just dealing with x equals 4.
Oh.
Now we'll talk about x equals 2. This also has an odd degree, so these are going to go in opposite directions, which does mean it must have done this and come back
Wait, what
down.
if one of them had multiplicity?
If it had multiplicity 2, then they would go in the same direction. In other words, you would have like, here's my vertical asymptote, this would be going up, they'd both be going up, or both be going down.
But if you have 3 and then it's one's multiplicity 1 and one's multiplicity.
It's just about what happens if that asymptote.
I'm just thinking for this graph, like because if it has to be the opposite of one, but it has to be the same as the other, but the two are both on.
But you're just looking at this one spot. So like, because it goes up here, it goes down here, and you're ignoring the rest of the graph. But there's another comment I want to make. Put your calculators down for a second, please. We found one x-intercept confidently. Why am I bringing that up? And it's here at 1. It is not between 2 and 4. Go ahead, Sam.
So if it doesn't cross the,
X-axis.
then it would, yeah.
Then there's no way it could have gone up
Yeah.
on either side there. Interesting. So it all does fit together, which is nice. Now, again, I think there were downsides to this question because of the level of detail. So it must be time to do Sam's question. Okay, here we are. Last one, and then we're going to quit. I will post homework. Actually, I might even tell it to you if I brought it with
So
me.
it's so lopsided.
Yeah. Well, and the lopsided thing is another thing I wanted to talk about today, but I guess, well, we'll see. Let's do this, and then if we have a couple minutes, I'm going to introduce one more idea to you guys. Okay, so let's go for it all together now. If we go to factor this, I'll remind you that cubes factor. That is a difference of cubes, and that is the factor of a difference of cubes, which you'll all recall from earlier this year. Easily, right? At some point, in some way, you will know that. Okay, anything canceled? Since nothing cancels, what does that mean I can conclude?
No.
No holes. Okay, so let's do everything else. We'll start with our va,
I'm gonna go to home.
and then we'll do our ha. Va.
Like they're crazy.
You guys just want to work. I'm just going to let you know. You're funny. Ha. Okay, we're analyzing the relationship between the degrees. It's top heavy. In other words, the top is growing faster than the bottom. It's not going to level off somewhere. There is none. Oh. Okay, well, since there's no horizontal asymptote, I now need to ask the question about an OLA or an oblique asymptote. By the way, if I do this division, since the degree on the top is 1 higher than the bottom, when I do the division, I'm going to end up with something linear. So it's going to be a linear oblique asymptote. We're not going to actually look at anything but linear oblique asymptotes, but there is a concept of like it following a parabolic path, still calling that behaving asymptotically. Ooh, isn't that a nice word? Okay, so if I do my long division, can we cut to the chase actually on this? You guys can all check Sam's long division later. What did you get when you did long division?
I get y equals x.
And you ignore the remainder, because there was a remainder. So y equals x is our oblique asymptote. You all know what that graph looks like, right? Please say yes. Thank you. X-intercepts? Okay, I'll do the easy one. 1, 0. What about x squared plus x plus 1? Does that factor? No. Okay, so my next move is to see, is it going to give me real answers? How can I fairly quickly check that it's going to give me real answers as opposed to imaginary answers? Ben?
B squared minus 4AC.
Yeah, the discriminant. So b squared would be 1 minus 4 times A sub C, is that gonna be positive or negative?
It's not gonna be real.
It's gonna be negative, therefore not real. That's my only intercept.
Hey-oh.
That was fun. See, that was so nice that we had that like quick tool. And to be honest, the discriminant doesn't come up for me often as being useful, but here's a place where it really is. Y-intercept, I'm plugging in 0 for x. I'm gonna do that at the very top. Give me 1/9. Yeah? Okay, oblique asymptote. Goes through the origin, up 1 over 1. Vertical asymptotes. Intercepts. 0, 1/9. Okay, that's really small, so it's somewhere like that. Wait. Oh, and that's going to cross right over. No, it's not. It's right above my oblique asymptote, isn't it? And then 1, 0. That's nice. And that's kind of all I have to go on. Okay, well, let's think about our rule from before that says if the multiplicity of the denominator of the things that make your vertical asymptote are odd, then things are going to go in opposite directions around the vertical asymptote.
It's gonna come up,
How do we know that?
because the first one's negative, which means it's gonna be going this, like, downwards.
So I still feel compelled, and you might be right, but this is my compulsion. I kind of feel like I still want a couple of values. Like I want to know what happens if I plug in 4. Well, 4 cubed minus 1, which is the easier place to plug this in, 4 cubed minus 1 is 63. And then 4 squared minus 9 would be 7. So that's 9. Yes? Did I do that right? So that would be the point -4.
Wait,
Whoa.
is that a -4 there?
That I plugged in?
Yeah.
Yes. Yes. So this is really -65, which is therefore not 9. But it's a negative number, okay? Negative number bigger than, or like more negative than 9, right? -9 plus change. Thank you, Eliza, that saved everything. So this would be -4 and then 9 is that, so it's like here. Like right underneath there. Which is enough for me to feel comfortable saying it's now going to live in here. Here's what you don't know until you take calculus. You don't know where this point is, where that turnaround is, and that's okay. All right, so now let's think about those vertical asymptotes. We said if they have the, actually we'll plug in one more number. What if we plug in +4? Then we get 63/8/7, which is 9, right? So that's going to be for 9. Oh, so this is going to be in here.
Is there ever,
Notice how I'm following the asymptotes.
is there ever gonna be a situation where it's a graph like this when both of the obliques, it's not gonna fit into that little triangle?
Graham had one that looked slightly different, but there weren't as many, like the asymptotes were a little different. Okay, and lastly, what we just learned from what I read to you is that because the multiplicity of the factors in the bottom that gave you the vertical asymptotes are both odd, then we know if it's going down here, like right here, for those of you watching this on TV, then it has to be up here. And since it's going up here, it has to be down here. So it seems to me that our graph has to look like that. It is very cool. And they're fun to draw. But if you get caught, plugging in numbers is an awesome way to go. If I give you one like the last one that I made up that was horrible, then the number plugging in is really exhausting and painful. But if it's a well thought out problem in less than a second, it tends to work nicely. All right, I'm dismissing you to go to a meeting. I will post homework around lunch, okay? Can everybody say what they need to say?
Bye.
Bye.